Hello, everyone. So I think I'll turn this presentation into a two-part presentation. Who of you has seen my talk at GraphQL Europe by any chance? So not enough, I am afraid. So sorry for that. So that's why I kind of, you have to wait for the Game of Thrones bit a little bit, but only quickly. I want to first quickly go over how graph databases are actually kind of well suited for GraphQL, and what we built so that the following presentation is easier to understand for all of you. So GraphQL plus graph databases. I mean, GraphQL has graph in its name, but it's in query language for APIs, so many people are confused and think, is it a graph database query language or not? And how can I combine them or not? And of course, you can do it. So for graph databases in general, it's actually pretty straightforward. So whatever you draw on a whiteboard in terms of entities and connections between these entities can be represented kind of one-to-one in a graph database. So you have people, you have events, you have locations, you have companies, and so on, and you then draw connections between all of them, and that's kind of the data model that a graph database has. So kind of what you have on the whiteboard is the same that's in the database, and it's really nice. So, and the nice thing is also they can store properties on your relationship. So for instance, if you talk to someone, then you can put, for instance, the date or time when you spoke to the person. On the relationships, you have this information there to qualify it. So that's kind of the basic model of a graph database. And what I said, if you put it on a whiteboard, then pull it out of the database, it looks the same. So which is kind of nice because you don't lose all the non-developers who can't see the forest for all the tables anymore. That's cool. And so what we also did, we built our own query language for graph databases because we felt that something like SQL with joins or extensions still looks quite ugly, and we wanted to kind of preserve the richness of the drawing that you can do on a whiteboard in the query language as well. So what we did is we created ASCII art because, you know, being nerds, ASCII art is really cool. So we just turned the circles into round parentheses and the arrow into a kind of visual arrow that you can use to kind of draw out your patterns that you're interested in. So a person loves another person, a person works at a company, a person attends a meetup, someone speaks at a meetup about a topic, and the topic is related to other topics, and so on. You can imagine it. It's kind of growing pretty quickly. And so the query language looks pretty simple. So you kind of draw these patterns, and then you write something like create this pattern or match this pattern, and then you can do like the regular filtering, aggregation, and so on. So that's what it usually looks like when you talk to Neo4j. But what does it have to do with GraphQL? We felt that it would be kind of cool to combine Neo4j with GraphQL, and of course you can do the regular thing, just write your GraphQL server connected to a database like you do with Postgres or Mongo or any other database. Just write your resolvers, and that would go to Neo4j, do the queries, and return the fields. But we've also wanted to play around into turning Neo4j into a native GraphQL backend, because we had some ideas and wanted to see how that works and how hard can it be, right? So we take the GraphQL query, we transform it into our own query language, execute it, return the results, right? As you all know, GraphQL is schema first, very much reliant on a schema as the contract between the backend and the front end. Unfortunately, graph databases tend to be schema free or schema optional, so there's not much schema in the database itself. So which schema do we use? Of course, we use the GraphQL schema. So that's actually a nice addition that we get for free by just saying, okay, the database doesn't really care, but we have the GraphQL schema, so let's just use the GraphQL schema to define our schema. So we do that. And the cool thing about Neo4j is that's both open source and extensible, so we can just build an extension, throw it in, and then suddenly you have an HTTP endpoint which can talk GraphQL to the outside world. How hard can it be? It took us, I think, a few weeks, and actually we used Kotlin for it, and it was quite a pleasant experience. And if you haven't tried this language on a JVM, then I recommend you to try it out, because it's the nicer variant of writing code on JVM, much better than Java, and not as strange and understandable as Scala, especially if you have nice functional expressions, but then you pass in the wrong collection type, and then suddenly something horrible happens. So Neo4j GraphQL is an extension that can do stuff that you kind of regularly think of, like having a GraphQL endpoint. You can post a schema file to this endpoint, and it will kind of accept the schema file and use it. You have basic auth. You can run queries against it and get the results back. So that's the basic stuff. It creates a single query that goes against the database, so it doesn't do a resolver for every field, but it just turns your whole deeply nested GraphQL query into a single query, sends it to a graph database, and gets the result of all the nested levels back. So it's not n+1 select or something like that. It's just a single query that's executed and returned, which is kind of nice. Something else that we did is we just auto-generate mutations for all the types. So you can create entities, you can delete them, you can update them, you can create connections between entities, and have support for things like attrelation, order by first, offset, and all this sort of stuff. And have unlimited nesting as well. And the really nice thing is that you can add some power-ups, like an add cipher directive, which allows you to annotate a field or a mutation or a query type with just a directive and put in some cipher, so the query language that you saw before. And then you can, for instance, have suddenly a field on a movie that's a recommendation field. So you would kind of have a single field that returns related movies by collaborative filtering or some enhanced graph query in the back end. And for you don't have to write really custom code, but you just extend the schema with an annotation or a directive, and then you get automatically this stuff out of the box, which is kind of nice. Cool. It's easy to use. I show you actually practically how it works in a few seconds. And let's do that. So that was just the intro level quick thing, which I just have to get rid of. So, and now the fun begins. So who of you has watched the last episodes of Game of Thrones? Not all of you? Okay, so I tried not to spoil anyone if you haven't caught up, which might be a little bit hard. So we had a lot of fun with Game of Thrones in lots of different ways, because it's an interesting world, it's an interesting story, and many people die, and you have lots of fun events, magic, and so on. And there are lots of data sets there, and there's also a lot of interesting connections between people, the story, and so on. So I was looking for some map data on Game of Thrones to kind of create spatial stuff around it. But I didn't find really good map data, but what I found was actually an API. So someone sat down and took the data from the Song of Ice and Fire wiki and extracted it all into JSON and runs a server that serves all this data as an API. So you can just use any REST call to extract the API, get information about the people, locations, and houses, and so on. So which is really nice. So I thought, oh, cool, let's use that, and let's use this data a little bit. And so it's a really nicely documented API. It's called an API of Ice and Fire. There's a documentation page, and it has data on all the books, 2,400 characters, and 444 houses, which was kind of surprising for me because I couldn't remember to have read about 444 houses. And so it's a regular API with paging and all the stuff that you kind of are used to. So for instance, here is the API call for Daenerys Targaryen. And so you have a character, and then depending on the importance of the character, you have a lot of data or you have just a little bit of data. And so the first thing that I wanted to try to do is to just load this data from an API, from the API. And if we do this here, it looks like this. So I just can run this API call, and then I get the response back. Pretty straightforward. So if I were to take this data and turn it into a graph, what can I do? I can just take, here's my Neo4j instance, and I can just call apoc load JSON, pass in the JSON URL, and then goes to the endpoint, pulls the data in, and then with this data available in Neo4j, you can then start to create nodes relationships and create this kind of whole complex graph. So this was nice. And so first thing I did was to try to really go over the API, pull the data from the API kind of page by page and create all this stuff, which worked okay, but was not as nice as I wanted it to be. What I then did was I kind of took a step back and said, okay, actually I want to play around with my shiny new Neo4j GraphQL extension and see what all the bugs that are hidden inside and how does it kind of deal with real world data. So I thought, okay, let's just leave the import aside for a bit and let's try out the GraphQL extension. So what I did, I just took the documentation of the wiki, of the API. So the API documentation has for each entity, it has a detailed documentation of all the fields and how they interrelate and so on. And so I just took this information and turned it into a GraphQL schema in IDL. So you have basically houses which have names and titles, and someone founded a house, someone inherits the house, houses are allied to each other, follow someone else, and so on. Someone is the leader, the current leader of the house. They even have, some of them have ancestral weapons, and most of the houses also have words. Then houses have seats, which are also in a region. So you have kind of this kind of geo aspect as well. And then of course you have people, which again have names, aliases, appear in certain books or TV series, which belong to a house or are married to someone, have a father, mother, and all this other stuff. So that's kind of my GraphQL API, and you see that's pretty straightforward. The only thing that's kind of different from what you might have used so far is the @relation directive, which kind of maps back the GraphQL API to kind of the underlying graph database schema, which you could even leave off if you wanted to, but it's nicer to provide this information because then it has the information about directions of relationships. So for instance here, this is an incoming direction. So I can just take this schema, and if I find the right screen, oh, I remember something, I just forgot to record the screen, damn it. So we get a midway recording. Oops. Okay, so I just have here my Neo4j GraphQL with the schema file, and if I run this, it will take the schema file and then connect to the Neo4j sandbox, which I find probably here. So Neo4j sandbox, I can just log in with GitHub, for instance. Then it spins up a Docker instance on Amazon in ECS and installs the GraphQL extension, posts the schema file, and provides me with the author information for this instance, and then I can access that. So if it's done, then let's see how long it takes. Come on. Demo effect. I hope we're not out of, there it is. Okay, so it spun up the Neo4j instance and has all the stuff. And now I can actually connect to the GraphQL endpoint here. I have a basic auth header, which I just keep around for a year. And I can also access and build in graphical, so which currently does not. Why doesn't it work? I hope I didn't break anything. Let's see. Demo. So this didn't work. Let me just quickly try this again. I just kill this instance. Come on. Okay, let's try it again. Otherwise, you do it locally. So what I can tell you meanwhile is, so the next thing that I'm gonna do is use the GraphQL CLI client tools from GraphQL to connect to this instance and get the schema from that index instance, and then we can, for instance, look at the schema with Voyager. There we go. So let's try this again. I hope I didn't mess up the schema with anything. No. It seems that I somehow messed up the schema. Anyway, let's see if we can still use this instance. So we also have a Neo4j browser, of course, that powers, or the Neo4j that powers that. So if I do call GraphQL.schema, then I should be able to know it. So it seems that I messed up the schema file somehow. So let's try to post this directly. So we can call GraphQL.idr and then just paste in the schema file as well and see. So this looked okay. Okay, this looks better. So something with the posting of the schema file didn't work. So I have here now my schema in graphical houses, seats, regions, people, and I could also run queries, but currently the database is empty, which is not so helpful. I can also run the GraphQL schema thing here that gives us the visual representation of our GraphQL schema. As you can see here, we have the houses, people, and connected with all the connections that you saw in the schema before. And now what we can do is actually, I just steal the basic auth token and the URL. Let's start with the URL. So we can do now, let's see, GraphQL init. So I installed the GraphQL CLI file. Let's use schema.graphql. Endpoint URL is my endpoint. And I just call it Game of Thrones. No subscription URL. I don't want to add any other endpoints, and I want to save this as JSON. So if you know GraphQL config, then you might be aware of this format. I just quickly want to show you this. So this is kind of the basic endpoint configuration. Unfortunately, we have to add the auth manually. So let me do this. So I just said that I just wanted to copy the auth header here. And then I just steal the thing from over here. Basic auth is this. And so unfortunately also GraphQL CLI by default just writes the single URL thing here, but we actually need the full URL. So that's a bit tricky. And so imagine this would gotten set by GraphQL init instead of me manually messing around with this file. Now we have this thing, and now it should actually work to use GraphQL Ping, and if the auth header, if the auth header is set correctly, GOT. So Ping worked. So it sends a type name query to this endpoint. The auth worked. So for instance, if I mess up the auth by just changing this auth header here and run this again, then it does not work. It complains. Oh, it doesn't complain. Damn it. Oh yeah. Let me just delete all of it and then. So security auth error. So this took me a little bit when I first tried this out. The next thing that we can do is we can do GraphQL get schema. So it will pull the schema. I think I had this here because I tried something else and So it pulls the schema, and if I look at the schema.graphql, this is now much bigger than our schema that we had before because it also includes all the auto-generated enums, all the auto-generated mutations, and all the auto-generated query fields. So it's quite a lot of stuff. So all the sorting and so on. But you see it's still the same stuff, it's just more, and it also pulls the comments as well. So which is kind of nice, because if you change it, then it shows you the diffs between schemas and stuff like that. So that's quite useful. What I can also do is I can do GraphQL Voyager, which would run in local Voyager, localhost 7000. Oops, wasn't it? Oh, there it is. So which also shows us our schema again. So that's a plugin for GraphQL CLI from GraphQL, which is really nice. Okay, now we have our database, but it's empty, which is not really useful. So let's get the data in. And so as I said before, I started by querying the API. But then fortunately, I actually noticed, Joachim, the author of the API, had also the data in his GitHub repository. So the JSON files with the data were actually in the GitHub repository. And then, of course, it's much easier to just grab the data from GitHub and kind of skip the API altogether. And that's what I did in the end. I saved me all the kind of effort of doing the full API calls, because then you had also to page over it and so on. And so the only thing that was a bit annoying was there were some annoying empty and null and empty collection fields and stuff like that, which I didn't want to have. And his JSON files all had capitalized keys, which I also didn't like, so I just changed this on the fly. And this is my cipher statement to create all the characters with their kind of data for the character, then all the allegiances, fathers, mothers, spouses, and so on in one step. So if I now go to my endpoint here, to my Neo4j database, and run this, it goes to GitHub, pulls the data, creates the graph, and we can see that. So it's the 2,400 people that it pulls in. So if you look at this, then we see also all the people here now in the graph. So you see also they are allied with houses and so on. But because the connections to the house is only by ID, they don't have a name yet, so we also have to import the houses as well, which is this other statement, which looks similarly a little bit ugly, but that's also because I do it all in one go. So I do all the houses, whom they are all allied with, the seats, the regions, branches of houses. What else do we have here? Who is the founder? Who is the current lord? Who is the heir to the house? And so on. So all the stuff in one go. Fortunately, it's only 444 houses, and pulls the data from GitHub and creates it in a graph. And now we see all these relationships. So for instance, we could see all the parental relationships. So this is, for instance, here Targaryens. Here in the middle, then here we have Hightowers, the Freys. This is Targaryen as well, large family, and Greyjoys, a little bit of Greyjoy here as well. So we imported all the data from the API, so the whole database is now full with Game of Thrones, and if you return all of it, actually, I wanted to return all of it, so that's why I have to increase some limits. Let's just add a 0 everywhere. And we can do this. And so we have 2,100 people, 444 houses, 12 regions, 24 seats, and you can see that it's a lot. So it also takes a while to kind of settle down, but let's see how far we get. Right. So that's the world of Westeros in the graph, which is kind of really nice. So when it's done, I think Chrome now holds my computer. So JavaScript and lots of data in the browser is not such a good friend. So, and I think this is these three here still, so that's not as fast. So you see, there's some structure to be seen, but it's just a hairball, more or less, right?
How long can your browser stand that?
It actually works for a while. I mean, that's why the limits are usually in there that I just removed. So usually I wouldn't use like these three for data volume of that, but something like ngraph or this.js or something like that. Okay, cool. So why doesn't, there. So it's a graph, because if you ever kind of looked for Game of Thrones infographics, it's all kind of all these connections between people and houses and all this stuff. So when it renders, it's done rendering, it looks like this. So you always see these clusters of people that belong to a certain house and so on. Okay, what can we do now? We can ask some questions. For instance, we can look at parental relationships. So one thing that we could do here is to say we find a person. So you see that if we kind of drawing these patterns where the name of the person is Stefan Baratheon. So I hope I got this right. And Stefan is a parent of children and grandchildren and grandchildren, right? So just all the way down, and this forms a path, so it goes like a tree thing. And if I return this path, then I see here a bit of the Baratheon. So where's Stefan actually? Here's Stefan, the parent. And then we have Robert Baratheon, Tom and Baratheon, Joffrey, and Stannis. But those of you who've kind of followed the books or the series, you see that there are lots of people missing actually, right? So it's kind of a small subset. And I was kind of confused by that because I thought, why is stuff missing? Then I looked at actually the JSON data, and it was really missing from the JSON data. So we can actually look for missing data as well. So what I had here is we can also just run a query which says, find me a person. Find me a person who appeared at least in 2 TV series, so it's kind of important person, 2 seasons, and that don't have a parent off relationship either point to a person or going away from the person. So it's not a child and it's not a parent. So it's an important person, but there is no parental relationship. So and give me like 20 of these people. And if I look at these people, or let me just return the name of the person, p.name. So we see Waldo, which is actually Hodor. So for Hodor, we don't have parent relationship. Margaery Tyrell definitely has as a parent, right? And Tywin Lannister, of course, has children. As you might know, Aemon Targaryen is a son of one of the old Targaryens. Lester Thorne has a son. Arya Stark, of course, has parents. Ashak Greyjoy has a father. Bastion Sammy, and so on. So you see that for quite a lot of people, actually, data is missing. So we could actually go back and help Joachim to improve his data quality by just finding these kind of gaps in the data and helping to fill them, which is kind of nice. For instance, Brienne of Tarth also has her father actually in the books. So that's nice. The other thing that I wanted to show, so that's kind of what we can query with Cypher, but of course, we also want to query with GraphQL because just querying with Cypher is kind of boring. Right, so that's why I just take this query here so that I can just run this. And we had our graphical here somewhere. So we can also do it ourselves, right? So we have a house. Can you see that? So we have a house with a name. House stock of Winterfell, and then we just want to return. What's it doing? There's one parenthesis too little, right? What? So, I can do it like this. What? But we have the house is query. Oh shit! What happened here? This is definitely wrong. Why does it have the movie database? That's stupid. So I think that's something that was messed up with the init script. Let me just take this again and call GraphQL. So this is, of course, demo level. So now we have all this stuff here. We just refresh, take this again, prettify, run this. Okay, cool. So it doesn't refresh the schema. Let's do this again. So now we have seeds, houses, regions, and so on. That's why it didn't work. So we have house stock of Winterfell. We want to see the name, the words, the founder's name, where's the seed, where's the region, who does this house follow, and who are the followers of this house, and their seeds again. So kind of the nested stuff, right? And if I run this, then I get Winterfell, winter's coming, Brandon Stark, so one of the old Brandon Starks, as you probably know, founded the house. And so we see all the other information. We could also say what are the ancestral weapons, for instance, or who is the leader of this house, and for this leader, what else can we see? What are the aliases of this leader, or something like that. And then it just does the thing. So we don't have a leader. Great. But we can, what else do we have? Oh, we have an heir, perhaps, to Winterfell. Let's see if we have heirs to Winterfell. No heirs. I mean, it's a lot of heirs. But we can, for instance, do it for the founder and see if we have also aliases for Brandon the Builder. I think it's Brandon the Builder. Yeah. So you can do a regular GraphQL queries as well on this. So this was the first bit that I wanted to show you. The other thing that I started to work on Friday, I think, is an GraphQL CLI plugin that allows you to load data from CSV or JSON files. So you have your GraphQL endpoints with mutations, but then you have data in databases in CSV or JSON, and you want to use the mutations of your GraphQL endpoints to feed or seed your database with data, which is kind of common. And I don't really know what you use these days, if you kind of feed the backends with data usually, or use SQL or something like that. But I found it kind of nice to have the GraphQL CLI be able to load data. And so I thought, how hard can it be? And I went on a plane with no internet, and then coding stuff like that without internet is kind of annoying. But I got it to work, and I just wanted to show you what it looks like. So what I can do, so this GraphQL load extension can use a JSON or CSV file, an endpoint, and a mutation. Actually, I have an example here. Where's it? Yeah. So here are my mutations. I just grabbed them from the schema file, so I can create houses, seeds, regions, and people, and then I can kind of connect them by calling add seed to houses, add region to houses, and so on, kind of ID and area or list of IDs. And so, if I want to create, so I have my local database here somewhere. Where's my local database? Here's my local database, I think. Yeah. So this is my local database, which I can quickly empty out. Oops. So, okay, it's empty. I already posted the schema to this, so if I do call GraphQL.schema, I see this is the schema that you saw before. People are connected to houses. And now if I want to load the data, I just say, I'm not sure if you can see this well enough here, or if we just make this terminal smaller and move it upwards. Come on. So I have GraphQL load. I pass in the JSON file, which is actually the JSON file from your Kim's GitHub repository, which is already like object by object in an array. Then I provide the endpoint, which should be probably just a parameter behind it. And I can provide the mutation, which is at house. You might see it there, going over there, at house. And I can also provide a mapping. So if my columns in my CSV or my fields in my JSON are spelled or named differently than the mutation fields, I can provide a mapping between the two. So for instance, I have here in the JSON, it's all capitalized, but my mutation has lowercase keys. And so I just use this houses.json file, which is here, looks like this, like one object per row with all the data, 444 of them. And if I run this and everything works, which I hope it will, here's my full. So this is just adding them. So this is the full mapping with the correct create house mutation. So it passes the JSON into 444 rows, generates the call, and then runs the insert. And if I look at my GraphQL endpoint, and then I see all the houses in there. So it inserted all the houses with all the properties. So if I look at any of these houses, I can also see all the properties that are coming from the JSON. So, and the next thing that I can do now is to run the same for characters.json, correct. So, so this takes a little bit longer because it's 2,400 and sends it as one GraphQL mutation query, and takes a few seconds, and then it's done. Yeah, now it's done. And so I probably, going forward, I will split it up into smaller calls that just batch them into pages of 100 or 1,000 or something like that. And if I look here, then that's my. Then I suddenly have all the people as well in the database. So these are all the people. So I can count them. 2,134. And then as the last thing that I can do is actually characters. So here I call a mutation that connects a person to its spouse, to their spouse, so husband or wife, and I just map the ID of the person to the ID field, and the spouse field, which is a single ID, also to this spouse field in the mutation. And if I run this, it goes also over the 2,100 people, and then creates the connections between them, and it probably not a refresh time. So we have now the spouse relationships, so we see how people are connected in their parental relationships, in their spousal relationships, sorry. I mean, in Game of Thrones, it's not so easy to say it's a parent or a spouse or both. No. So that was something that I thought could be useful and helpful. I would love to get some feedback on that. So if you want to try it out, so it's called GraphQL CLI load. You can just install it with npm and try it out. So that would be cool to see if that's useful for anyone to use. Okay, and then I just have a bunch of more stuff. So it's all on GitHub. I wrote it up on Medium. There's also actually a contest. So if you want to do something with GraphQL and Game of Thrones, then where's my contest? Somewhere's my contest. I messed it up. Lost my contest. Somewhere's my contest. So we have 7 weeks, as long as the series runs, of contests who build stuff with Game of Thrones data, and you can win cool stuff that you can, find yourself. So you can decide what you want to have, a T-shirt and other stuff as well. So, and there are also links to the APIs, this GraphQL CLI load that I just showed you, and there are all the Neo4j GraphQL stuff that is out there, and lots of other stuff where people used Game of Thrones data by using NLP on the books, by using character interactions from the books to kind of find interaction graphs. looking at the math behind that whole thing, and or using the Kaggle data that's also available for Game of Thrones. Okay, cool. That was it. Questions, comments?